Okay, hey everyone, Matthew here, and in today's video I'm going to be starting my Android Forensic series by talking all about files, encryption, and storage. Now, the goals of today's video are to go over what types of files that we see on Android, where we find them, and a little bit more about how the Android file system is organized in the end. Now, at the start of it all are files. What are files? So files are important containers for data in a computer. So files are all just a sequence of bits of a certain size that store certain data in a certain type of structure. So whether it be PowerPoint presentations like this one, which is probably stored on some server somewhere in California or something like that, or a picture file, or a file of some texture in a game, or just anything else, that is a structure that has a certain amount of bits in it and it is stored on a computer. So the way that computers find out how to do this is by using file signatures and metadata. So a file signature is just a basic sequence of bits that allow us to identify a file. So for instance, JPEG files start with this, and we can actually look at lists of these types of these sequences of bits. So if we look at file signatures, there's the Scary Kessler site, and this file signatures Wikipedia file. And it has pretty much everything that we can find for file signatures. But the main takeaway I want to be from this is that file signatures have different bit sequences that you can see when you open it up in a hex editor. Now, speaking of hex editors, I want you to feast your eyes on this example of a file. So if we open up this image inside of a hex editor, we find that it's a JPEG, and we find that all JPEGs or all JPEGs that are like this start with a sequence like this and this GFIF at the top. So that there is something similar to, I believe, what this is. And that is a good file signature. And up to a certain point, there's metadata that talks about the color types and when this was made and where it was made and stuff like that. And then after that metadata is data about all the pixels. So starting from
the relevant website, you'll be prompted to notify the people
from this left corner to this right corner, row by row down until it gets to the last row from corner to corner. And then at the end of it all, there could be an I in there, but that is most likely the end of a PNG file. Now for Android and files. So Android has been around for a while. It started its conception in about 2005, and Android in its form as a mobile operating system came about in 2000. Actually, 2007. I should change that. It was 2000 or 2007 to 2008. So Android was originally a camera operating system, but the Android team said, "Oh, we shouldn't make a camera operating system because we're kind of limiting ourselves here, and also this market is extremely, extremely competitive." So in the end, what they did is they said, "Okay, let's go back to the drawing board and make a mobile phone operating system. So at this time that Android was being conceived was a little bit before the iPhone was introduced. But smartphones like on operating systems like BlackBerry OS and Symbian Mobile, among other things, were very popular. So what they did is they wanted to make something to compete with those, and also something that would allow for a lot of innovation over the years, and they ended up being successful in this endeavor, giving us the Android operating system with a certain architecture. So over the years, Android grew and grew, and architecture changed a lot, very much over the years. I remember
You've added to the group via
I remember back in my high school days that Android looked a lot different than it does now on the user-facing side, and as I was learning about Android, I do realize also that on the internal inside, it looks a lot different than it did then. So that was about 10 years after this date, which I originally got into Android, and now, about 8 years later, Android has changed a lot. So, but there are a few basic standard file types that haven't changed in their usage in Android. Those being the text file, which is just a basic store for text, the APK file, the application package kit, which makes for easy distribution and install of apps. Now, to get into this, an APK stores data and information about app, and when it's executed, it pushes everything into something that looks like this, to something that looks like this, org.mozilla.firefox, or a .com.something type of file. And we could see here in our folder, if we go to it, if we go to our folder, it's already over here. If we go to our folder over here, and we go to data, I'll explain this later, but we see that everything here is either a com or an org at the beginning. And these are all apps that were somehow downloaded and installed through an APK. Now our DEX is our Delvec executable. So for those of you Windows people, it's our .exe file for our Android phone. And in this case, the Android system has this DEX in the background, and we can't directly look into this. But what we can do is open the app shortcut, and this app shortcut is ultimately a program that links to this DEX file and executes the instructions to open the file. Now, we also have JSON and XML files, which are two different types of ways to store some sort of key value type of data. So JSON is a JavaScript object notation file, and this is a human-readable file that stores data in our convenient key value structure. Now, we'll discuss the structure later, but Now we can see that XML is just executable markup language, which is JSON, but basically the HTML version of JSON. Now, .SQLite files, .db files, and all of those other types of database containers store some sort of SQLite database. And this is a convenient table-like structure akin to an Excel spreadsheet that allows you to make queries that are sometimes advanced to help you get to data that was stored within it. And level DB files are hidden SQLite files, SQLite DB files, and .db files too. But level DB files are Google's version of SQLite files. And in our case, with an SQLite DB file, we find that we can query up a bunch of info. We can query up a bunch of info in an SQLite reader, like this one. So we have different tables here, and each different table has its information about it. And this different information can be read in different ways, and we'll learn about what this blob right here is in the next lesson or the next few lessons. But this blob can store very important information about whatever is in this field. And what I want you guys to take away from this is that there's a whole lot of information that our device can store very easily. Now, JSON versus XML. So both of these store some sort of key value pair. So in this case, JavaScript object notation or JSON is super cool because it's just essentially a line like this that's with an open brace and closed brace and its key or key pair, which is this, which is first name or last name, and John Doe are each of these things as value. Now with XML, it's a bit more complicated. So you have to define up here the version name and the encoding type, and there are also tags like this. So we have a note tag right here and the closing of the note tag. So you always, when we're looking at XML, we have to always make sure that our tags are opened and closed. Now, encryption is a very important part of Android. And it is a data privacy measure that allows us to keep some types of data hidden. And on a system level, there are two types of encryption, a credential-based encryption and a device-based encryption, which I will get into next. So when it comes to credential encryption needs a password. So every time the screen is turned off, credential encryption things are not available. And these things are photos, videos, logs, and other types of things. So I'll show you this now. Let's go back up one level. So CE, MISC CE we have system CE and user CE, or not user. And vendor CE. So let's see system CE, for instance. So we have recent tasks, recent images, and snapshots. So if we look into snapshots, we can see that the system logged usage of a USB tethering, which is USB tethering for file transfer here. And we can also see that there was a picture taken of, it looks like a paperclip, or something like that. And we can also see that there are XML data about recent tasks. So, and if we open this XML, we see that, yes, this was for a setting task. That this was for a setting task, and it has all of these properties to it. Now you can find a lot of other data, but for the sake of time, I will leave that to later. And DE, or device encryption, is another thing, because it's done on successful boot. So certain things like system logs need to have the system be on in order to work properly. So, and we can also see that here in our file system. So if we go into any of our DE folders, such as systemd 0, we can find that there is information about cached ringtones. I don't know how to open that. In SP blob. So which is probably password files stored in blob data, which you'll learn about next, but that's a binary large object. And we also have miscde 0 and storage-d, which has nothing in it, and void, which has nothing in it either. And vendor-d, which has nothing in it either. And now we can get on to what a file system is. So we've been leading up to all of this with our conversation about file types. Now, a file system is just basically a way of organizing all those files bitwise. So when we take a look at a file, it's just a series of bits. Now, this series of bits can either be all in one take, or all in one take linearly. So that's not Paint. So let me open up Paint. So let me open up Paint. So like I said, with linearly, so and 9, 10. So let's say each of these blocks is 4 megabytes wide. 4 or 4 kilobyte wide blocks. So if we have a file labeled file 1, file 1, file 1, file, so they'll be stored sequentially like this, but say comes along a file 2. Okay, so say we're writing a thing in Notepad and another thing in Notepad that we save onto the disk. So file 2 is 4 kilobytes saved, 8 kilobytes saved, and then we get another Notepad document and we call that a 3. So we see that things are no longer able to be stored sequentially. So 12 plus 8 is 20 kilobytes, 24 kilobytes. 24 kilobytes of our system have been used. Just in this area of our storage alone. 24 kilobytes have been used. So say we go back to 1 again and store something, and then 2, and then 1 again. So then that's what a file system normally does. In these days, it goes like that. But say we're running on a solid state drive, it would be all of this stuff would be accessed pretty rapidly, but still kind of slow. So what the operating system would like to do is keep everything in line once. So it defragments everything by just reorganizing everything into blocks, so that it can be easier to access the files at every point. And moreover, if a block like this is probably halfway filled, so which is 2 kilobytes, that this area right here is called slack. It's called slack space. So what slack space has, so slack space is just unused space that can be written to again. And with that slack space, I think the operating system also likes to make a few blocks room for more stuff to be written to the file, so that it doesn't go through slack and have to write to another place at the end of the tape. Now, why I said this is because there are a few different types of file systems. So overall, we have the YAFS, yet another flash file system, which is what Android's default file system is. And this is more than likely able to do more than 4 gigabytes of data, a 4 gigabyte data file, which is something that FAT32 or the file allocation table 32 style is not able to do, because it is a 32-bit file system, and as a result, consequently, it can only store about 4 gigabytes max on a file. Now, exFAT, or extended file allocation table, is something that's often used in SD cards that are on Android devices. which Android devices that we capture may or may not have. And this is because some devices like the OnePlus 8T are made unibody, while others like Samsung Galaxy Tabs these days are made unibody but have SD card slots. And these SD card slots allow us to add more storage to the device. And file systems like exFAT have very big file sizes. So big that exFAT can't even store files. Its biggest file on a modern day SD card.
Have to do this.
Because its max file size is 512 terabytes, which is orders of magnitude larger than the maximum SD card size, which I've been able to find, which is 2 terabytes. Now, VFAT or virtual FAT is what we get when we have a system that is newer than about Android 7, and we mount our SD cards to system memory to be used as system memory. Now just keep in mind that you'll see these on investigations in certain places. Now let's look back at our file system to discuss some of the main partitions. So we start off with the boot partition, which is not present here. Boot chart. You know that's not boot. But what the boot partition would do is, the boot is an area where scripts related to system startup are located. And as well, the system partition, which we do have here, has a bunch of aspects related to our Android operating system, and some of the preloaded apps on the device also do live here. A recovery partition, which is not present on this one. No, it's not. Are information that will help the phone repair a broken installation. Now the data partition, which is our data, has all of the data related to the apps that are on the phone, as well as other utilities too. And these can either start with a .com or a .org, like we saw with our Firefox. We have a cache, which stores data related to the frequently accessed data that needs to be referenced often, and our MISC, which stores miscellaneous data and settings about apps and other processes on the device. Now there are some other notable partitions that we could take a look at. So if there's a .sd card partition somewhere here, which there is not in this one, but if there were, that would mean that an SD card was attached to the phone or tablet or any other Android device, and that it's able to be looked at from here. And we also have /local/temp, /local/temp. It may include app data, and other rooting or exploits could have information here. So this is probably something that I can open in Notepad. But this is BusyBox, a utility that's used most notably for rooting a phone. And yeah, this is not readable on my computer. But yeah, so we also have the media partition, which we can open now. So OB has nothing, media 0, contains folders like DCIM, data from apps like Signal. You can have music, pictures, ringtones, podcasts, and a bunch of other stuff. And the cool thing about the media folder is that it can contain pictures from the phone's camera, images, videos, and downloads that the phone had on it. So like this profile pic and this picture of a LARPer is doing something. And Minecraft and images of other things. And speaking of Magisk and rooting, which we have here in the ADB folder and a few other places, like a lot of other places, rooting is something that we do on Linux. So it's as easy on Linux as issuing a command sudo su, which gives you root permission, which is super user or admin access for those of you Windows people. So by default, on an Android system, which is Linux kernel at its base, we don't have access to any ways of getting to our sudo permission. So we have to use exploits in order to get into that. And you use extra steps like downloading Magisk, which has utilities made by developers to run it. And you can get some hands-on experience with doing that on your own with this tutorial as homework. But if you don't have an Android device or don't want to do it on your own, my suggestion for what you guys could do today is just, again, go through the folder that I have linked, and in doing so, just find out whatever interesting data that you can find, and this data can be from any type of file, so SQL databases, it can be from pictures that are on the image, it can be from other files, it can just be anything that you want. And just note this down on a report for yourself, and you don't have to show me this report or anything, but just have it so that you know what in this topology on this phone, which we'll discover later is Android 9, how Android 9 stores all of its stuff. Now, with that out of the way, I'd like to leave you with this. We're going to have a lot of fun later on doing Android forensics, but for now, thank you for watching. Have a great day, everybody, and enjoy Android forensics.